Understanding SQL for Data Management. Title: Understanding SQL for Data Management. Introduction. In today's data-driven world, effective data management is imperative for organizations to stay competitive and make informed decisions. Structured Query Language, SQL, is a powerful tool that enables efficient manipulation and retrieval of data from relational databases. In this article, we will explore the fundamentals of SQL for data management, its key components, and its relevance in modern day businesses. Section 1. What is SQL? SQL, short for Structured Query Language, is a standard programming language used for managing and manipulating data in relational database systems. It provides a simplified and standardized approach to interact with databases, irrespective of the specific database management system, DBMS, being used. SQL allows users to define, retrieve, modify, and manage data effectively. Section 2. Key components of SQL. 2,1 Data Definition Language, DDL. The Data Definition Language, DDL, in SQL is used to define the structure, relationships, and constraints of a database. It includes commands such as create, alter, and drop, which are essential for creating and modifying database objects like tables, views, indexes, and constraints. DDL ensures the integrity and consistency of the data stored in the database. 2,2 Data Manipulation Language, DML. The Data Manipulation Language, DML, in SQL is used to manipulate and retrieve data within the database. DML commands, such as select, insert, update, and delete, enable users to perform various operations on the data. These commands allow for querying, inserting, updating, or deleting records, and are fundamental for day-to-day data management tasks. Section 3. SQL Queries and Retrieval. One of the primary applications of SQL is querying and retrieving data from databases. The select statement is the most commonly used SQL command for querying data. Using select, users can filter, and aggregate data based on specific criteria, enabling them to extract the required information from large datasets efficiently. SQL queries can be as simple as retrieving all records from a table or as complex as combining multiple tables using joins and applying various logical conditions. SQL's flexible syntax allows for creation of advanced queries, making it possible to extract highly specific and relevant insights from the available data. Section 4. Data Manipulation and Modification. SQL's DML commands enable users to modify and manipulate data within a database. The insert statement allows for the insertion of new records into a table, while the update statement enables the modification of existing records. Using the delete statement, users can remove unwanted records from a table. These data manipulation commands are vital for maintaining accurate and up-to-date data. They provide the means to add, update, and delete information as required, ensuring the data is consistent and aligned with changing business needs. Section 5. Data Integrity and Constraints. Data integrity is crucial in any database management system. SQL provides mechanisms to enforce data integrity through various constraints. Constraints help specify rules that the data must adhere to, ensuring its quality and reliability. For example, primary key constraints ensure that each record in a table is uniquely identified, while foreign key constraints establish relationships between tables. Other types of constraints, such as not null and check constraints, enforce the presence of certain values or the adherence to specified conditions. The usage of constraints in SQL guarantees the Accuracy and consistency of data stored within a database. Section 6. Creating and modifying database objects. Aside from managing data, SQL allows for the creation and modification of database objects such as tables, views, indexes, and stored procedures. These objects define the structure and behavior of database, thereby enabling efficient data management. SQL's DDL commands, such as create and alter, provide the capability to create, modify, and maintain these objects. Additionally, SQL permits the creation of views, which are virtual tables generated from queried data. Views can simplify data access by presenting a subset of the data or combining data from multiple tables into a single virtual table. Section 7. Data security and access control. Data security is a critical aspect of data management, and SQL offers features to enforce access control and protect sensitive information. SQL provides the ability to grant or revoke permissions on database objects, such as tables and views, to ensure that only authorized users can access and modify the data. Users can be assigned specific privileges, such as select, insert, update, and delete, allowing them to perform only the necessary operations on the data. Additionally, SQL supports the creation of roles, which can group multiple users and assign privileges to the role rather than individual users, simplifying access control management. 7.1 User authentication and authorization. SQL supports user authentication mechanisms, such as usernames and passwords, to verify the identity of users accessing the database. This ensures that only authorized individuals can log in and perform actions on the data. User roles can also be used to determine the level of access granted to each user, providing granular control over the data. 7.2 Encryption and data masking. To further enhance data security, SQL offers encryption features that allow data to be encrypted before storing it in the database. This ensures that even if unauthorized individuals gain access to the database, the data remains protected and unreadable without the appropriate decryption keys. Data masking is another feature provided by SQL that allows sensitive data to be replaced with fictitious values or masked values, ensuring that only authorized users can view the original data. This is especially useful in situations where developers or testers need access to a database but do not require access to sensitive information. Section 8. SQL in Business Intelligence and Analytics. SQL plays a significant role in business intelligence and analytics. It enables organizations to extract valuable insights from their data by performing complex calculations, aggregations, and transformations on large datasets. SQL is used extensively in data analysis and reporting to retrieve specific information and generate meaningful visualizations and reports. This interoperability expands the capabilities of SQL and makes it a powerful tool in the field of data science. Section 9. SQL in Web Development. SQL is widely used in web development for managing data in the backend of web applications. It enables developers to create, retrieve, update, and delete data from databases, providing the foundation for dynamic and interactive web applications. SQL statements are embedded within server-side scripting languages, such as PHP, Java, or Python, to execute database operations seamlessly. SQL's ability to handle complex queries and transactions efficiently makes it an ideal choice for web applications that deal with large amounts of data. It ensures data integrity and enables fast and reliable data retrieval, contributing to the overall performance and usability of web applications. SQL, short for Structured Query Language, is a standard programming language used for managing and manipulating data in relational database systems. It provides a simplified and standardized approach.